Good morning, good evening, good afternoon, depending on where you are. Today is February 16th, and this is another of our bi-weekly work group batch uh, calls. My name is Mati, and I'll be your host today. And I see that we have topics on the agenda already from Aldo, so I guess Aldo, take it away from here.
Yes, Maciek, thank you. Do we already have screen sharing permissions? I think so.
You should be able, let me stop sharing, but you should be able to share your screen.
Let's see. Is my screen visible and can you hear me?
Yes, we can hear you, and we see your Q.3 progress report presentation.
All right. Yes, so slideshow. Okay, so today the developers of Q wanted to share some status report of how we're doing towards the next release of Q, which is the 0.3 release. So my name is Aldo. I'm joined by Marcin as from GKE and Kante Yin from DAO Cloud. Um, so we we already announced a few things that we are already targeting for the V0.3 release. Um, one of the big updates is that we're going for our first beta APIs. And this is going to be quite breaking. I'm going to give a summary of the changes. But the whole point of going to beta is that from now on, we will have backwards compatibility guarantees. So from now on, you wouldn't be, you will have time to migrate and proper tooling for migration. Um, and an important feature that was highly requested from the beginning of the project is preemption. And I'm gonna talk also a little bit about how it works. Another feature request was some form of all or nothing, which we implemented through uh, waiting mm, for pods to be scheduled. And also some other contributors help us add end-to-end tests, which are now part of our pre-submits. So that has helped us spot some problems before going to master or to the main branch. Um, and we had some performance tests written by Oginskis initially, and Marcin is going to show us a few results we got from running those load tests. Um, Also, we have other ongoing efforts. I'm happy to announce that we have a new website under the 6.kates.io domain. So that's our new thing. I don't. Let me quickly share. So still in a way work in progress. We applied for CNCF to help us with a logo. So that's coming next. And but if you want to collaborate and you have some um, you know web experience, please don't hesitate to help, or if you just can design and so on. But we already migrated the docs, so now they look pretty nice, pretty neat. Um, so that's the website. Let me let me go back here. Uh, we also Kante here is gonna talk a little bit about our plans or for a library to be able to integrate custom jobs. So far, Q has only supported the job API by default, while it is possible to already add a controller that integrates with Q. Um, we want to offer a library so that it's very easy to write these controllers. Um, and kind of parallel effort with that is that we are already adding support for Qflow's MPI job. by Michał and Yuki. Um, so that's already ongoing. Anyways, I wanted to highlight the changes we plan for beta. This I think this is the if you look at the slides later, you'll find all the links to the docs or PRs and whatnot. But I wanted to highlight a few changes. In particular, this one, we at GK we actually ran some UX research studies, and and also from feedback we got from early users, we learned that people didn't understand or got confused with these two terms that we use for quota, min and max. Um, so we did a bunch of brainstorming to figure out how to properly name these fields, but and we just ended up with these two names, which we hope are more understandable. So here we're saying that the CPU resource has a flavor of spot, and we have 40 CPUs available of quota. Um, Now, the next field is a borrowing limit, which means once you have reached your quota, if your cluster queue belongs to a cohort, then you can borrow quota from these other cluster queues in the same cohort. So, and then this is the limit of how much you are able to borrow from all those other cluster queues. Um, so I guess one thing to note here is that now instead of max, we are doing the extra, which is 60. So then 60 plus 4 is the old max. And another thing to note is that these two terms match the API fields in API servers priority and fairness, if you're familiar with it, which also deals with quotas and sharing and so on. So they already had decided these two terms, and we found out that they fit nicely with our semantics as well. So we are doing that. Uh, yeah, so with that, I wanted to also give a shout out to Jordan Liggett, who uh, gave us quite a few hours of review of the API. So we did all of this while doing this proposal for a beta API. Now, still in the same object, we went a bit further. So you can see here on the left, kind of the updated um, spec for the cluster queue. So basically, you can see that we specify multiple resources, CPU and memory, and then for each resource, we specify flavors. Uh, and for each, we specify the quota. Now, what's the problem here? So usually, things like CPU and memory are very deeply coupled because they are tied to the node. So usually you want the same flavors to be listed for CPU and memory. And of course, you cannot assign a flavor of spot to CPU and then a flavor of on demand to memory. That would be incompatible. So in a way, we actually want to define a flavor instead that has the flavor gives you CPU and memory. So that's the change we figured it was needed. And to give a counter example, here we have, for example, a license, which a license probably is not tied to the VM, right? So it doesn't have the same flavors as the other resources. So now you have well, we just put some boilerplate here, but let's say you have license for the operating system, so you have only this quota for Windows and this much quota for Linux, and then this is not tied to the other resources. Anyways, so since we have these semantics of resources that are tied to each other, we made it explicit. So we're defining this what we call a resource group. So in a resource group, in this case, it's composed by CPU and memory, and for this group you have flavors. So you have flavor spot and you have a flavor on demand, and for each flavor you have different resources, um, and have the quotas for each. Here I left out the borrowing limit just to simplify the view here, but you of course you can have that as well. And then for license would be a separate resource group, and again you have the flavors for that resource group. Um, so I think those are the changes to the API. We hope it's gonna be more explicit and also easier to understand from the beginning. Uh, and of course, we are pairing it with updated documentation. Um, any questions here? Uh, okay. Actually, I don't know if there is a hand or anything. I don't see the screen. I only see my slides at the moment. So
No,
please,
there are no hands.
okay, sounds good. Sounds good. Um, so the next feature that we have been working on is preemption. So in preemption, I wanted to exemplify with this graphic here. Let's say you have this nominal quota for team A on the left, on the green, and then this nominal quota for team B uh, in orange. Now you have this usage, this green block. So these two cluster queues are tied together, meaning that they can share resources, they can borrow resources from each other. So let's say team A is currently using this using extra quota that team B is not using, right? Team B on the right is using less than its minimal quota. Then team A can borrow the quota that B is not using. But now we have a new job coming from B. So B wants to recover its quota because it belongs to it, it's part of his part of its nominal quota. So what should happen here is that Q needs to preempt some workloads that are running in this quota to accommodate for team B, for the new workload from team B. So that's one scenario of preemption, that you want to recover quota from cluster queues that are currently borrowing from you. So that's the semantics here. You can see that the API is pretty simple. Just there's a preemption field, and then we can say when reclaiming from within the cohort, here there are some options like you can reclaim, you can disable it, you can say never, you can say always, or you can say I only want to preempt if the priority from the priorities, I only want to preempt workloads that have lower priority than me. Uh, and just as a reminder, this cluster queue is an object that administrators set up, not users, not end users. So this is setting policies, right? This is setting policies from the organization, whether the preemptions should respect or not. The priority might depend on your needs. Um, another scenario for preemption is within the cluster queue. Let's say there is no more space to borrow. Team B is using everything. You have a high priority workload coming for A. Then in that case, you might actually want to preempt some workloads that are running within the quota of A. So that's the second scenario, and this is the second field, the policy that this second field is controlling. So preemption within cluster queue, again, you can say never, you can say lower priority. You cannot say always because that wouldn't make sense. You wouldn't want to preempt a workload that has higher priority to accommodate a lower priority one. But you can say you can disable Steam. So that's preemption. This is already merged. We don't have a release yet, but so if you are interested, you can for sure try it out in the main branch. Mhm. Any questions about preemption? Okay. Um, this is the next feature we did that is also merged. Uh, Waiting for jobs to be scheduled. So this is actually a startup configuration field. So this is how you can check the documentation. Actually, this link might be no, it's a new link. Yes. Uh, so yeah, so this is a configuration field for the feature. Wait for pods ready, and you can enable and disable, and you can set up a timeout for how long you're willing to wait for pods to be ready. So what's this for? So when you enable this feature, Q will wait for the pods of a job to be ready. Uh, if you follow the progress in the job API, you might know that there is a field, a new kind of new field called ready in the job status that tells you if the pods are well scheduled and already running. So we use that field within Q to gate the jobs. So we wait for a job to schedule to start up, and only then we schedule the next job. And this offers all or nothing guarantees when either you have a very fragmented a cluster that could potentially get fragmented easily, namely uh, um, fixed size cluster, and or if you are prone to stockouts, which are possible in uh, is possible when you're like requesting way too many GPUs in the cloud, or some other uncommon or highly demanded piece of hardware. So yeah, this is a kind of a first attempt at offering all or nothing, but keep in mind that this is not what we intend to have long term. Long term, we want to have uh, deeper integration with cluster autoscaler, so that cluster autoscaler can give we can have a feedback loop between Q and cluster autoscaler, or the scheduler, or both, to inform Q that a scale up was not possible, or a scheduling uh, all or nothing scheduling was not possible, so Q can back off uh, the next jobs. So that's the long term idea. Yeah, Marcin, can you take it from here?
Sure. So we run a couple of performance and scalability tests on Q. While we don't have any specific scenarios, we thought that a couple of them would be quite interesting. The first one focuses on comparing how much overhead brings Q over job controller. So we try to create 100 jobs, 5 pods each. Each of the pods running just pause for 2 seconds, and we were creating 10 jobs a second. So we measured 50th percentile of time from the moment that the job is created in etcd to the actual start of the job, and then from start to finish. We did these measurements on a 12 node cluster running 4 CPU machines on GKE. And the results seem to be very, very similar with Q and without Q. Both create times were 14 and 13 seconds, and time needed for jobs to be started were also similar. We tried also creating large queue inside of queue. We submitted 7,000 jobs. The queue didn't crash, and the memory consumption was at reasonable level of 500 megabytes. Okay, that's all. If you have any ideas for performance tests and you would like to check the scenarios that are common in your company, please let us know.
Yeah, so two things. Victor's, who originally wrote the scale test, did it through cluster loader, which is a highly configurable framework for building load tests. So it's very easy to set up. Now it's super easy to set up new scenarios, you know, with the jobs, the number of pods your organization might have per job, and yeah, you can tweak all the parameters, and then it's very easy to run the tests themselves. And another thing I wanted to highlight about Q, why the memory consumption is low, is because Q takes decisions at the job level. So even if your job has hundreds or thousands of pods, that doesn't matter. That doesn't increase the memory consumption of Q, because we just look at jobs. So the more parallel your jobs are, the happier Q is. And any questions about performance or any of the topics?
I think we disable the wait for pod to ready the issue case, right?
Sorry, I completely missed the question. Can you speak louder?
I guess we disable the feature gate about the wait for pod ready when running the performance test, right?
I'm so sorry. I couldn't understand.
I mean, we disable the wait for pod ready, right?
If we tested with pods ready?
Yeah.
No, this is using the default configuration, which doesn't use pods ready. Yeah, that could be easily added, but we haven't tested yet.
Hi, Aldo.
Yep.
Just a question. Have you measured how deep the queues can actually get with the queue system?
How deep in like pending?
Yes, exactly. Yeah.
Yeah, so this is the second scenario we talked about. Yeah, we just basically created pods, like 100 jobs per second or something like that, and we just let it hold. And yeah, so the memory consumption was 500 megabytes for 7,000 jobs. So that's the main consumption, but latency wise, it doesn't, like 7,000 is still not. It's still nothing. We just used one core, and that was enough.
So queue will buffer jobs in a queue outside of the Kubernetes scheduler?
Right. So queue would hold the jobs so that there are no pods actually until queue says we have quota for this job, and then the job controller is able to create the pods, and only then kube scheduler would take over. So yeah, that in a sense, queue will reduce the memory consumption of the entire cluster when you have way too many jobs. yeah, because there are less pods overall to process.
Okay, thank you.
So remember that like all these jobs are actually created on the API server. So there is a dependency on how scalable the API server is as well. Like if you create, it's not like Q is like, you know, the front end that receives and stores these objects. They are all on the API server. So just like, I think this is an important thing to basically note. And do you have like specific limits that you've tested before, or you think are more reasonable to test in terms of like number of jobs, pending jobs?
You mean so the number of jobs that will be queued at any one time?
Yeah.
So I think we do on the order of what, 1 million, 2 million jobs a day, something like that.
But all of them exist on the API server or outside?
No, we keep them outside.
Yeah. All right.
Yeah, one thing we did notice is that we sometimes run into the limitation of the API server itself, that once you have too many pods, each of the kubelets is sending status updates, so the entire API server is slow. So you need a beefy master or a beefy API server to handle those kind of loads. So and a queue is highly dependent on that size, on the size of the master. Anyways, if there are no more questions about our what we already talked about, I'll leave it to Kante.
Yeah. You know, currently we support Kubernetes native job in Q, but we want to for the more types like the API job and so. So we can choose this just as a scaffold, and so you don't need to build your control from scratch. And to achieve this, we defined a new interface named we named the generic job, but the name is still redesigned. And it reshapes the default behavior we need to integrate with Q. And you know, the most known spanner capacity, like others. Besides this, we hope to provide a full controller. So it indicates that all we need to do is just to implement the interface, then you will get the full feature of the controller, and you just call the controller. That's all what we want to do. But there is still something unsettled. So, but the good news is that NPR job will be the first volunteer, and let's see what will happen. And I think Misha is working on the NPR job controller, right? And that's all.
Thank you, Kante. Any questions about this? I had one thought about this, I forgot. Let's just continue. So as usual, we are always looking for contributors, not just contributors in code, but documentation, or now the website, and just general feedback. Oh yes, so for example, I left in the notes for today's meeting the links to some of the PRs and whatnot. For example, the custom job library. If you have any feedback or you're already thinking of integrating with Q, it would be useful to have your feedback to adjust if needed. But in general, we have other tasks for grabs. For example, partial admission of jobs, where you might have a job where, ideally you want 10 pods, but you're okay with 5. So those kind of scenarios. And integrating with pprof, so that we can measure at a higher granularity the performance of Q, and some like user experience improvements, such as a kubectl plugin, and perhaps even Grafana samples to build dashboards. We already have metrics, but we don't have ready-to-use Grafana dashboards, which it would be nice to provide. And there's some like people asking about Helm and other deployment mechanisms. So if you have any experience with any of those, you're welcome to contribute. And I think that's all we have for today. So I would like to leave the last 10 minutes for any questions.
Okay, folks, does anyone have any questions for Aldo and the team?
When can we expect the release?
Good question. So we are finishing up. I think the biggest change that we're still implementing is the API updates. It's touching every piece of Q. So once that's finished, we just need to update the documentation, and we have a tech writer help us with those changes. So to really bring the best quality to the documentation, and I would expect, maybe around 4 weeks to the next release.
Okay, folks, don't be shy. Does anyone else have any other questions?
And I suspect everybody knows. I didn't say what Q is. I assume everybody knew, but if you don't know, please ask now, and we can clarify.
Or check the new docs page.
Yes, beautiful web page.
Okay, I'm not seeing any raised hands or any questions in the chat. So with that, I will give back everyone roughly 9 minutes of your time. Thank you very much all for today, and see you next time. Bye all.
Thank you.
Thanks everyone. Take care.
Thank you. Bye.